Alright, now we're going to talk about measuring area and volume. We'll start with area. We use squared units to measure area, like square feet, square inches, square centimeters. We end up with squared units because of how we might find the area of like a rectangle. That's sort of like the easiest way to think about it. When we find the area of a rectangle, we simply multiply length times width. So if we have a rectangle that is 3 feet long and 4 feet wide, then the way that we find that area is we multiply length times width. So we have 3 feet times 4 feet. And so we have 3 times 4, which is 12, and then feet times feet. You know, we think of these feet as just these things attached to the numbers, but they're kind of like factors as well. Feet times feet is squared feet. So we get 12 square feet. So that's sort of just a way to understand why we end up with squared units. You could also sort of see that we can kind of cut it up into these squares. And I know my drawing isn't quite drawn to scale because they look more rectangular than perfectly square. But we have, you could count them up, right? We have 12 of these squares, square feet. When we convert units of area, we have to be a little bit careful. And we're still going to use these linear conversions, like 1 yard is 3 feet. And we could do a area conversion using the linear units, but first we're going to see, you know, a certain pitfall we could encounter. So suppose I want to convert 4 square yards to square feet. So I start with the given, I put it over 1 because I need it to look like a fraction. Now, if I try to use this equivalence, and I put yards on the bottom because I need them to cancel, I end up with a bit of a problem. Right? Yards squared, like square yards, is yards times yards. So I'm just going to rewrite this like that. Now when I go to cancel, only one of the yards units cancel. I end up with 12. 4 times 3 is 12, and then my units are yard feet. And I guess I could think of that as a unit. That's a really kind of confusing kind of unit. It doesn't really mean much to anybody who would see this figure. And it certainly did not get us to square feet, which is what we wanted. So we need to make an adjustment. Now we're going to redo this same thing. Now, what we need to realize is that 1 squared is equal to 1. That's not an earth-shattering fact, but remember that these fractions that we use when we are using dimensional analysis, they're equal to 1, right? They're these unit fractions. So that means that 3 feet over 1 yard, that's equal to 1, but it's also equal to 1 if I square it. And the way you square a fraction, as long as there's no addition or subtraction, and we're fine, right? Just have 3 feet on top, 1 yard on the bottom. But the way you square a fraction is you square everything in it. So I'd have like 3 squared feet squared over 1 squared yard squared. So this is how we can still use these linear equivalences to help us do a conversion with area. So we'll do the same problem. 4 square yards, I put it over 1. I start with this linear equivalent. 1 yard equal to 3 feet, and then I say, you know what, this is not going to be good enough, right? This isn't going to work out the way I want it to because I have yards squared and I need yards squared. So I want more than anything for that yards to be squared. And because of this fact up here, because they're unit fractions, I can go ahead and square that as long as I square everything in the fraction. Now, the yards squareds cancel. I have 4 times 3 squared, which is 9 feet squared. And I'm left with square feet. So 4 times 9 is 36 square feet. Now right here, when we use this trick, this technique where we could square everything, we basically discovered that 1 square yard is equal to 9 square feet. And we can visualize that, right? If I have 1 square yard, right, 1 yard by 1 yard, that's like having 3 feet by 3 feet, and we can count them up, right? We can see that we do in fact have 9 square feet here. For a lot of area conversion problems, we simply will use our linear equivalences and just use that technique when we can square everything in a unit fraction. So if I wanted to convert 3.2 square meters to square feet, I'm going to start with my 3.2 square meters. Put it over 1 because I need to look like a fraction. Now I need to get to feet. Or square feet, but I'm going to try to get from meters to feet first. I'm going to use that equivalence first. And I think I've got to go find my list of equivalences back here. So there's no feet to meters perfectly listed here. I could do this a couple of different ways. I guess maybe it'll be faster if I go from feet to centimeters first. So 1 foot is 20.48 centimeters. And so what I'm going to need to do first is get myself from square meters to square centimeters. But I'm going to think about this in terms of just meters to centimeters first. So 1 meter is 100 centimeters. We do have to be a little bit careful, like you might be thinking right now, can't we just do the move the decimal trick? And you can do that if all you're doing is converting a base unit to a base unit, or not, sorry, a base unit like linear unit to another unit, like from meters to centimeters. But to go from square meters to square centimeters, that's harder to do. So I'm going to just use the equivalence, 1 meter to 100 centimeters. I'm going to square everything. Now I'm at square centimeters, right? If I cancel stuff, I'm at square centimeters. And now I can use this equivalence over here, 20.48 centimeters to 1 foot. And because I was at square centimeters here, in order to get them to cancel, I need this to be squared. And I'm allowed to square the centimeters if I square everything in the fraction. And now I'm left with square feet. So what we need to do here, so you'll notice, right, this was a couple of steps in this unit conversion. And that's one of the nice things about dimensional analysis. Even if I had to do many steps, I could just sort of chase the units through this process. But now in order to finish this up, what I'm going to do is take 3.2, I'm going to multiply it by 100 squared, and then I'm going to divide it by 20.48 squared. And I get 76.29 square feet. Now we also have units of area that aren't necessarily like squared. Like the acre is just an acre. We don't have square acres. But an acre is about 43,000, or exactly 43,560 square feet. In the metric system, that analogous unit is the hectare, and 1 acre is about 0.4 hectares, or 1 hectare is about 2.5 acres. You're not going to probably come across hectares much unless you buy property in Europe or something. But that is sort of the analogous area unit in the metric system. Now let's talk about volume. Volume has cubic units like cubic feet, cubic centimeters, cubic meters. And we'll do a quick example here. How many cubic centimeters are in 0.23 cubic meters? So I'm starting out with 0.23 cubic meters. Now again, because these are cube units, you know, just like with the squared units, I can't simply use the move the decimal trick here. I have to be careful, but I do know that in 1 meter there are 100 centimeters. And this time, in order to get my meters to cancel, or my meters cubed to cancel, I want this to be cubed. And just as before, if I want to cube that, I can, as long as I cube everything in the fraction. Now we can see that the meters cubed will cancel. I'm left with cubic centimeters. And I'm going to take 0.23 and multiply it by 100 cubed. Which is 230,000 cubic centimeters. Now there's another way to measure volume, or another type of units that we use to measure volume. Here we have these cubic, or these cubed linear units, but we could also use what are commonly referred to as units of capacity. They are, like in the US system, we've got like the gallon or the fluid ounce, you know, how many cups, how many pints. Those are capacity equivalences. And this is what we use in the US system. In the metric system, and we'll talk about that in a minute, we've got our base unit is the liter, and then we have exactly the same prefixes as we did with the meter. So let's do a quick example here. A swimming pool has a volume of 22,500 cubic feet. How many gallons? So they're giving us the volume in cubic feet, and we want to convert that to gallons. So if I look up here in my list, I have an equivalence here from cubic feet to gallons, and we can use that. So 22,500 cubic feet. Got to put it over 1. I need it to look like a fraction. And then 1 cubic foot is 7.48 gallons. I need cubic feet to cancel. Those have to go on the bottom. Notice the cubic feet, like the feet were already cubed in this equivalence. I didn't have to cube anything. So I'm not imposing any exponents. I'm not cubing anything in this fraction because the units already worked out. And I'm left with gallons. So we have 22,500 times 7.48. And I have 168,300 gallons. In the metric system, for measuring capacity, our base unit is the liter. And then we have the same prefixes. So I'm not going to talk about these prefixes anymore. They're written in the same order. I can use that move the decimal trick if I'm going from, say, kiloliters to liters or something. I know I would just move the decimal place, 3 spaces to the right. So these mean the same thing. That's one nice thing about the metric system is once you've learned what those prefixes mean, they mean the same thing regardless of which unit we're attaching it to. And then another nice thing about the metric system is there are really nice equivalences. I'm going to go back here and look at this last example we did, and how even when we were staying within the U.S. system of measure, to get from cubic feet to gallons, it was still an approximation. 1 cubic feet is 7.48 gallons, some weird number, like nothing. I mean, it's not like it's a super weird number, but like 7.48 gallons, and we had to approximate. With the metric system, we have this nice equivalence that 1 cubic centimeter is 1 milliliter, right? And then from that, 1 liter is 1,000 cubic centimeters, and then 1 cubic meter is 1 kiloliter. And we do this simply by multiplying by 1,000 each time. But 1 cubic centimeter is 1 milliliter, and that makes it fairly simple to do some conversions. So sometimes cubic centimeter is abbreviated cc. So in this example, they say we have an aquarium with a capacity of 36,000 cc's, cubic centimeters. And we want to get from cubic centimeters to liters. So I could go either way, but I think what I'll do is that will get us there the fastest. 1,000 cubic centimeters is 1 liter. So all I need to do now is take 36,000 and divide it by 1,000. That gets us 36 liters.